Welcome to a lesson with Dr. Powell. Let's take a look at how we can find the angle between two vectors drawn in three-dimensional space. So suppose we have one vector and another vector. Okay, just arbitrarily drew these and perhaps they're in the wrong places, but let's just put down coordinates here. Suppose we have 2, -1, 3, and maybe -1, -2, and 1. Let's find the angle between these. Okay, well, first, we can kind of make a triangle. Let's find this length right here. If we knew that length, then we could just take this length and we'd be set to go. We can just think of cosine. The cosine of this angle is going to be the ratio of adjacent to hypotenuse. What's the length of this? Let's find the length by taking 2 squared plus 1 squared plus 3 squared in a square root. Okay, and that's going to end up being 4 plus 1 plus 9, so 14, square root of 14. Okay, now this length, how do we compute it? Well, it's computed by the dot product of this with this guy made into a unit. All right, so let's make this into a unit vector. By dividing by its length. So 1 squared plus 2 squared plus 1 squared, which would be 1 plus 1 plus 4, so square root of 6. Okay, so we take the dot product of this and then divide by square root of 6. So take dot product to -1, that's -2, -1, -2, that's +2. 3 and 1, that's +3. And we add that together and we get 3, and then we divide by square root of 6. So this length is 3 divided by square root of 6. Okay, so how do we find this angle? Well, we simply just take the inverse cosine of this length, the adjacent, over the hypotenuse. So 3 over square root of 6 all over square root of 14. And that will give us the angle that we desire right there. Thanks for watching.